My name is Abdul Rafi and today I am going to tell you about DSP. So starting from lecture 1, what does DSP means? DSP consists of three words. D, that means digital, S means signal, and P means processing. So DSP is basically digital signal processing. In digital, if you break down into three parts, digital, signal, and processing, we get to know that digital means finite set of values to represent real world objects, whereas signal means physical quantities that change with respect to independent variables, and processing means transformation through algorithms and techniques. So when we combine all of these three words, we get to know that DSP means transformation of signals using algorithms and techniques in digital form. Let's have a look on applications of DSPs. DSP has vast applications in diverse fields. We get to know that from DSP we are able to do digital filtering, digital image processing, that means DIP, which is a separate course and will be dealt separately. Medical imaging like ECGs and etc. Bandwidth compression, that is too much important in telecommunication field, control and guidance, and DSP is also used in radar communication. If we talk about applications of DSP in telecommunication, we get to know that it has two main uses in telecommunication, that is compression and sorting. Now let's talk about compression. Why is compression important in telecommunication? It is important because it reduces file size, saves disk space, and reduces transmission time, which is very much important in telecommunication. Compression or decompression is performed using an algorithm which compresses or decompresses the data. Now let's take an example of compression. So suppose we have got three pictures like this: picture A, picture B, and picture C. Where for picture A we got for picture A, B, and C we got 400 to 600 pixels, which means that individual pixels of these pictures will be 400 to 600. That will be 2,40,000. Whereas if we combine the pixels of all three of pictures, we get to know that we have got total of 7,20,000 pixels. Here we will start at the compression technique. Compression techniques basically compares all of these three pictures that are being transmitted on the same channel. Now this technique will identify the differences between all of these three pictures. We get to know that at picture A got a single square inside, whereas picture B got two of them and picture C got three of them. So if we suppose that we have got this small square contains a pixel size of 10,000, so we can get to know that rather than transmitting all of these stuff on 7,20,000 pixels, that is the total of this, we can transmit it using 2,40,000 plus 10,000 for this small block and 10,000 for this small block, which means 2,60,000. You can see that 10,000 for that small box, 2,40,000 pixel. Now calculating overall pixels, that means 2,40,000 pixels of picture A, then plus 10,000 for small block, additional small block in picture B, and 10,000 for small additional block in picture 3. That means overall we got 2,60,000 pixels. Now if we suppose that we got a data rate of 10,000 pixels per second on a network, then transmission time for three pixels individually, picture A, picture B, and picture C, will be 720 seconds, whereas transmission time for after applying compression technique will be 2,60,000 divided by 1000, which will be 2,60,000. So which is much less than 720 seconds. So the average transmission the overall transmission time that is being saved is 720 minus 260, that is 460 seconds. So we have proved that after applying compression technique we can save time and data can be transmitted more. Now we will talk about binary sorting or searching. In binary searching or sorting, the data should be in ascending order, and it should have it is only possible in digital signals because digital signals contain finite values. Now let's take an example. We have got data from 0 to 100 that is sorted in ascending order, and we have to and our required result is 12. So now in the first iteration we will take the first value and the last value, that is 0 and 100. 0 plus 100 divided by 2, we will get a mid value of 50. We know that 12 is less than 50, so our required result is somewhere between 0 and 50. So in the next iteration we will we will search between 0 and 50. So 0 plus 50 divided by 2, that will give us 25. 12 is less than 25, so we again get to know that our recorded result is between 0 to 25. Now in the third iteration we will search between 0 and 25. That will be mid value will be 12. So we will get our required result in third answer using binary searching and sorting in ascending order. That's all for today's lecture. Thank you.